I recently built this physics-based stippling tool where shapes are physically simulated to reconstruct the original image. And today we are going to talk about how this works under the hood. So first we can talk about the UI. You can see there are a lot of different options. We don't have to just simulate circles, we can just use other shapes, but we can use even the random shapes. We have some shape radius, jittering options to make it more interesting. We also have the different spawner types. Again, we will talk about this, but this is because this is not real time, so we have to make it more interesting using the inspector. So as you can see, when I change the parameter or change the image, we have this loading screen. And why is this? Is because a lot of stuff is pre-computed before we see the simulation. And that's to figure out the pixel value when the simulation is actually done. So the easiest way to explain this is just to turn on the debug. And what's happening here is instead of the loading screen, we see really fast animation. Then we have these blue shapes, which are dynamic shapes, are the most expensive one in the physics engine. When they actually reach a certain threshold in their velocity, or their velocity is lower than some threshold, we convert those dynamic shapes to the static shapes, which are cheaper. And finally, when they actually reach some kind of lifespan, we convert them to the graphic shapes. There are some other optimization methods happening here to reduce the draw calls. So if I zoom in, you can see these are actually procedural shapes, dynamic and static ones, but the graphics one were procedural shapes, but we render them, we batch them on top of the one image. So basically all of this green part is one draw call. We just render image here, and here every single shape is a different render call. So to show it inside of a code, it's pretty simple. We have this update demo, which is when we turn on the debug, and this update game, which is actually what interested us. So we spawn dynamic shapes. That's how this is working. We do that every single frame. And then if we tests that this shape is idle, which means its velocity is under some threshold, we convert it to the static shape. And then if that static shape reached the lifetime, we remove it because we are gonna batch render it on top of the image, and we do that here. So we have two options. We can just draw it every single time, this graphic shape, or batch rendering, similarly to the update demo where we actually have this debug option. So if I make it true, and I can actually turn off the simulation optimization, then if I run it, basically we will have dynamic shape, static shape, which will be converted to the graphic shape, and they will stay procedural. And I'm not sure is it necessary, but basically if this animation continues, we will actually have it less and less FPS, because every single one of these, yeah, you can actually see it, every single one of these is now a different render call. So batch rendering of all of this is actually really helpful. Yeah, so hopefully this was useful to you and interesting, and yeah, thank you very much for watching.